Hello and good day to you. You're once again welcome to MESO Constructions, where we discuss all things engineering, architecture, and 3D modeling. Today, we'll be learning in Protastructure how to use your plane definitions to design a ramp, and we'll also be analyzing everything that we're going to be doing in this lesson. And we'll be starting from the basics, which is drawing your general arrangement, and then we'll proceed to install our columns, our beams, the slabs, draw slab streets, then go into drawing our ramps. Then we'll try to set up our design for analysis, and then we analyze. We are hoping that you'll be able to learn a lot from the tutorial video for today, and we encourage you to stay with us as we proceed. But before further ado, we want to encourage you to subscribe to our channel for more content like this, and turn on your notification bell to be the first to see our latest tutorial videos on Protastructure and structural engineering, and also the practical application of structural elements on site. Thank you. So let's go into our general arrangement. We'll go to modeling, and then we'll use orthogonal axis generator. So I could just click anywhere on this to generate my axis. So let me click somewhere around here, and we see reference point 2000 around X. So I want it to be somewhat, let's just say, let me just make it 17,000 here. You can adjust it. It's going to adjust where our point is going to be. So our insertion angle is 0 because we want our angles to be straight. Then axis label A, then that's our direction 1 axis. You could change this to maybe if you want your axis label to be in numbers or whatever you want it to be, and the direction 2 axis is 1, but this is the default, the standard default. So I'm just going to be leaving this like this. So now I have this, each spacing is of my axis is 5,000, and I'll be having 3 of those. I need more than 3, so I'm just going to make this, let's make it 6. I don't need up to 6, but I'm just going to make it 6 for now. So now I'm going to do that the same for the direction 2 axis too. So, and just as you have seen, axis and our axis label is here, and axis label is 1 here. So it will be 1 2 3 4 5 6 and A B C D E F. You understand? So we can go on to just click. Axis extension length is 2000 mm. So here too is 2000 mm, and I prefer it like that, which means that axis extension length is going to be 2000, and it's going to axis extension is going to run like 2000 off each other. So let's just click on that, and you see that this is the extension length, this is the length in between. So, and to confirm this, you can just use your measure, and you go here, you see this is 2000, and you can escape, then you go here and you see this is 5000, just like we did. So this is how you install your axis. And now that we have installed our axis, we can go on to install our column. So I want to draw a small structure, a very simple structure, and then we'll be designing our ramp on that structure. So if you want to draw your column, you just need to click on this. We've covered lessons on this in the past, and you can go check in the description for our lessons for our tutorial videos on this. So we want it to be 2 to 5 by 2 to 5. So we go here and type that. So we want it to be 2 to 5 by 2 to 5, and we want the eccentricity to be 0. So we are leaving everything here as default, and we want all our columns to be exactly, so we are not touching anything here. And starting with 1C1, that's the labeling of the column, the name of the columns. And this is our story 1. As you can see, we are working on our story 1 here. Story 0 is your foundation story. So now what I want to do is I want to insert columns here. You can actually insert the columns by just going to whatever point you want to insert your column, and then you insert your column. So I'm going to cover this 1 2 3 4 5. So I'm going to use just this section of my general arrangements to do what I want to do today concerning this tutorial. So let's just go here, let's install a column here. So you just need to click and click and click and click, click and click and click, as I want my ramps to really run through convincingly in a way that it can't be mistaken. So now we have how many columns now? We have 1 2 3 4 5 times 1 2 3 4 5. That's 25 columns, and you can see that we have 25 columns here. So now you can escape this and you can go zoom closely with your middle mouse button to observe the columns. So we have these columns here now. What we want to do now is we want bins on our columns. So you go here, click on bins, and then you can easily just draw your bins, like that. You can press your control key, to draw, but sometimes you will not need to press your control key. But when you need to make it straight, you can just do that. Now we forgot something. We forgot to give the dimension of our bins, and we want our bins to be 225 by 450. So that's 225, and then we have 450 here, 450. So what we just need to do now is that we need to update the ones we've already created. So I'm going to go to these bins and select all. I'm going to select all. I'm going to select all the bins like this, and I'll go to properties. Let's go to properties. So I'm just going to go to this, and I'm going to set to 225. Let me set it to 225 manually, 225, and press OK, and set everything to 225. Now go here, I'll do the same and set this one to 450. I think there's 450 here. Yes, 450, yes. So I'm just going to press OK. So because we forgot, we could have initially just set that, and we won't have to do what we just did now. So now in order to install the same length of bin for the others, what we just need to do is to click any of these bins, and then we start installing. So automatically it will sort itself out. So it will automatically sort itself out, and everything it will be creating will be just duplicates of the ones that we selected with the same properties. And when you go closely to look, you see that properties of the bin are actually the same. That's 225 by 450, and you can see it's written there. So you can actually take this also, and take it. So now this is where we want the ramp to be. We want the ramp to be somewhere around here. So we're going to be installing. We install the bin. So we'll install the bin across here because we want the ramp to be there. So now we have the ramp. This is where we're going to be installing the ramp, and we can go on to look at what our drawing looks like in 3D. Let's go make a 3D physical model, and you see this is what we have here. Now this is where we want the ramp to be. We want the ramp to be there, and we want the ramp to be, to be there, and we need it to be, like, what the ramp means, like a step. It goes up as a slab, then it comes back, So that's what we want. And let's go back to our story 1, and in our story 1 we can now install slabs. So let's install slabs here. So we can choose beam region, and we want our slab to be, so that we won't make the same mistake, to be 150. So the depth of our slab to 150, and we're going to just click the beam region. Since we already selected beam region, we're going to click this, and our slabs are installed. So but there's something we need to do, and we're going to do it right away, especially because we need a slab here, somewhere around here. The landing for the slab, for the ramp, is going to be somewhere around here. So what we need to do is we need to create an axis here, because axes are actually used to generate the structural elements in Protastructure. Without the axis, your structural elements will just be hanging, and that's even if you can install them anyway. So we need to create an axis here. So I'm just going to offset this. So I can go here and I can offset the axis, and since I know that the distance is 5,000, I can just pick 25. But it depends on the specification of your drawing, though. You don't need to follow exactly what I'm doing here. So it's labeling this H, and I don't want it to be in H. I want to just name it A prime. So I click on it, and I go here and I rename it A prime. Let me name it A prime. Then I update, and you see that it's written A prime there. So I want that here. Then for the ramp, the ramp is going to be one coming like this and the other one going back, so which means we need an axis in between these 6 and 7. So I can offset this and also by 2.5, then I escape it and I go and rename it. Let me rename it 6 prime. Let me rename it 6 prime, then I update it and you see that it's updated and then named 6 prime. So now what we need to do is we need to also create the slab here, and in order to create the slab here, I can just click on any of the slab to transfer the properties. Then instead of using beam region, I just go to pick points, and once I pick points, you see that it's going to insert my slab on the points I picked. So I also want to create the ramp right here and here, so I'm going to use the same pick points to do just that. Yeah, so let me pick points here. 2, 3, 4. So I'm going to pick points again. So yeah, so now that's done. When we go to our 3D now, you see that we have this slab right here, and what we want to do is we want this part to go down and I want this part to come back up here, which means all these are going down. So in order to be able to accomplish that, we need to use our plane definitions. So let's go back to our plan and let's try to use our plane definitions to get this slab converted into a ramp. Before we go into that, let's try to set slab types automatically. We can go to set slab types automatically by just clicking everything. So it says slab types that will be used in mechanism will be determined here. The slab will not be modified if the type cannot be determined. So now, we are applying to all slabs in story. We can also apply to all slabs in the model. Let's apply to all slabs in the story, since we just have one story, and you can see we have all our slab types here. So what we want to do now is we want to create a plane definition on our slab. So let's try to see if we can do it exactly the way it is. So let me just go here to click on our plane definition. So I'm just going to pick points. Yes, I'm going to pick points. I'm going to choose pick points. You have all these options. I'm going to go to pick points, as you see. So I'm just going to click this, and then I go here where I want my plane definitions to be at, and you see that it gives me P1 right here. So I need to create P2. So I'm just going to go here and replicate the same thing. So I'm going to go here and here, and you see that I have my P2. And then I'm going to go here also to do the same thing, because I want my plane that I'm going to give it P3. So I can go here and then go here, pick points and pick points and pick points, and you see that I have that right there. So now you have this plane here, P1, P2, P3. So we want this to go down and up, and we need this one to be the one that goes from the landing that is here up. This one is going to be the one that comes from the floor to the landing here, then this is going to be the one that goes from the landing all the way back up. So now that we have our P1, P2 defined, we need to actually assign heights to them. So let's go to our P1 to assign an inclined height or inclined angle to them. Not really angle, what we are dealing with is just a difference in height here. So, and you can see that it's labeled Z here. You have Z here. So this Z represents the height of your points 1, point 2, point 3, and you have 3 points here designated for this. And when you go close to what you have created, you see that this is point 3, and then for this plane definition 1, and you have your point 1 and point 2. This is point 2 here, this is point 1 here, because it's overlapping a lot. You have the 1, 2 and 3 for the plane definition 3 here, so just don't mix that up. So you have 1 and 2 for the plane definition 1 here, and you have 1 and 2 for the plane definition 2 here. So now we want our 1 and 2 for the plane definition 2 to be inclined to around 1500. That's half of the total story height here, and we want this one to be minus 3000. The 0.3 of our pin definition 1, we need it to be on the ground level, which is going to be minus 3000. Then we need the 1 and 2, the 0.1 and 2 of it to be around half of that, which is going to be 1500. So let's just set that right here. So we have 1 and 2 for the pin definition 1 to be 1500. So we're going to type minus 1500 because it's going to be in difference of the story height this time. And we need it to be minus 3000, which is going to be on the ground level. So we update that, and you can see that it has updated to minus 1500 here, 1500 here. Then you have 3000 up here, which is going to be where the ramp is taken up from. So now for the plane definition 2, we're going to have the 1 and 2 is going to be also on the landing, which is going to be minus 1500, minus 1500. Let's just go to plane definition 2 and select it. Then we have the 1 and 2, which is 1 and 2 to be 1500. Then we have the 3. We are going to leave the 3 just the way it is because the 3 is actually landing on the slab. So we're going to leave the 3 at whatever value it is right now. So but we are going to take the 1 and 2 and move it down, and we are going to set the values to minus 1500, and then you go here and set to minus 1500 also. So and we update. And once you do that, you see that z still remains 0, while the z of this is 1500 minus 1500, and z of this is also minus 1500. So now we go to the P3. So the P3, we have the 1 and 2 to be on minus 1500. Everything in P3 is going to be minus 1500 because it is the landing, and you know that the landing is actually stepped down to minus 1500. So we're going to make everything here to be minus 1500. And then update. So now you have all our pre-definitions well defined, and what we need to do now is we need to set the members to plane definitions. And in order to do that, you can just go to your plane definition, click on it, you go to move members to plane, and you press yes. And when you go to your 3D, you realize that whoa, everything is just wobbly. So what we need to do is we need to just take care of this, and then reset plane definition of members. Yes. Then reset plane definition of members. Yes. No, not for the slab. For this reset plane definition of members. Yes. So there's still something not right here. That's why our slab is like this. So we didn't get something quite right, and that's why the slab is like this. So I need to go back to the plane definition of 1 and 2. So let's go back to our plan. Sometimes it happens like that. So we have 3 here. Okay, it's because of the way we set our plane definition. So what we want to do now is that we want to change this. The way we set it, we're supposed to take this and make it 3000. Then we'll take this and make it 15. So let's try to do that now. So which means we are defining our plane definition differently. So we take this, and then we can take this and take this here. Then we'll take this, we take this, and then bring it here. So now let's take this to minus 1500. And let's take this to minus 3000. Let's take this to minus 3000. And let's update that. So we have 15 here, and we have 3000 here, and we have 3000 here. So now let's go ahead to remove members to plane definition. Yep. So let's go to 3D to check again, and you can see that it's now properly done the way we need it to be. So It's good sometimes that you make such, because it just helps us to be able to edit that error that we made initially. The first point that you are bringing down are supposed to be your 1 and 2, while this secondary points that you are leaving at a different height up is supposed to be just your 3 and then your point 4. Usually, because you have the luxury to only edit 1, 2, 3, so we need to designate the first 2 points for the part that you are bringing down. Now we need to go to our members to adjust the members. So we need to remove all these members from the plane definition because we want them to remain what they have. So we reset plane definition for this. We also reset plane definition for this, and reset plane definition for this also, and this also, yes, and this also, yes. So now let's go to this and also work on the plane definition. Let's go to plan. So now we have 1515. So this one now is not going to give us a problem because that's 1 and 2. When we remove plane definition to member, you see that it's not going to give us problem, and you can see that it doesn't give us any problem because we already set 1 and 2 to the part that is inclined and leave this other part that is not really as much inclined to be here. So now we need to also adjust the members here because the members are not where we intend them to be. So we remove plane definitions from them, and so that they will be where exactly they are meant to be. So we set plane definition, and then we go to these planes and we set plane definitions. So we set plane definitions and you have every other thing looking exactly the way it should be. So you have your lamp picking up from here and then coming down here. So this is also not going to give us a problem since everything is actually set to the same height, and we're going to bring down everything to the same height, and also the beam along with it. So in this case we won't be resetting plane definitions for the beam because we also want the beam to take the plane definition we have set. So, and you can see we set 1515 for everything. So what we need to do now is to just move members to plane definitions and press yes, and then go to your 3D to view on the slide, and you see that we have this right here. So the only thing we are moving here now, we are resetting is the column. So you leave the beam where it is because this ramp needs a beam to support it on the landing. So we reset plane definition for the columns, and then we reset plane definitions for the columns. Set the plane definition, and so that you now have your ramp designed on this drawing. So this is how you design your ramp. So you can go home to save your work right away. Then you can also go to your load cases, to adjust your load cases. I'm not applying P data analysis. It's not a very tall building that needs some concern for the slenderness ratio. So let's go to load generator to just go through it. So what I did here was that I'm not defining pattern loading automatically. I don't need this, so I just go straight to this. Then I can also check the steel and concrete and create factors, G plus Q combinations and all that. Then horizontal loading, I only need the notional loads. So I'm going to press OK here, and you see that it generates all these load combinations for me, which I'm very okay with. Then I press OK, and I have my load cases there. And then you can also move on ahead to adjust your loadings because we want to analyze this, so we can decompose load, by FE. So we have all these settings here. We're not going to touch anything. So you just go here and then you decompose your load. And once you decompose your load, see that it's not giving us any problem. It just decomposes the load naturally, and we have that going well for us. And you can close this and apply to all the beams in the model, and you have this looking good. And now you can go on to try to analyze your building, what you have drawn. But before you go into the analysis, you need this slab to also have a support, and the kind of support that we can actually install here is a wall. When you go to stage 0, you see that in modeling you can insert a wall, and what we can use to give this ramp a good landing is a wall. Even though this doesn't have a basement wall, so we need a support under it, and we can't add any other thing. So this is story 0 and we can insert a wall. What we need to do now is we need to create an intermediate story. Let's go back to our story 1. We need to create an intermediate story that will enable us to be able to put a wall here. It's going to be a wall that supports this slab, going all the way down into the foundation, because this is the foundation level. So we have the DPC level here, so we need to install a wall on the DPC level that will support this ramp. And in order to do that, we're just going to be creating an intermediate floor. So let's try to create an intermediate floor here. So we go to our stories, then we insert story, then you can call this story 1, and you press OK. And see that once you press OK, it disables everything, including the floor analysis. And see that we have the story right here now. So this story is the story that is going to the foundation. So what we need to do now is we need to generate stories. We take 2. So we want to generate a story into that story 1, because it has been that story 2 now. So all we want to generate is just the columns. We don't need any other thing to be generated to that story. So you press OK. So, and once you press OK, you see that it's looking like it's very long, but we don't actually need this story to be this long because we're not creating 2 stories. So what we're going to do is now just that we'll go back to our story, and then you can edit story. So we want this story to be just 150, and then we still need the total height of our story to be around 3000, because they are both one story. We are just using this additional story to add a wall to our ramp. We can subtract 3000 minus 150, and that gives you 2850. So which means this can be 2850, and then you have that, and you can press OK, and you can see that we still have our story level 3000 here. So, and you can press OK, and you can see that it has automatically installed that for us here, and we have our story looking good. Now the next thing we need to do is we need to add our wall here, but before we add our wall here, you realize that the slab is already tilting away from the DPC level, the damp-proof course level, that's the German floor level, and you need to move this ramp up. So in order to move the ramp up, you need to go back to the ramp settings. So let's create a new plan view. So, and this is going to be a plan view for story 2, because now ramp and everything is now in story 2. So you can go up and you go to this ramp, and you adjust this from 3000 to 2850. So we have 2850. So you update it, and once you update it, you can go on to check what it's like. You see that it's not yet updated, so which means what I need to do is I need to go to print definition itself. So I need to click on this, then move members to print definition, yes. So now once you move members to print definition, see that we have that story repeating itself again, but now it's where we want it to be. So we need to just remove all these from print definitions to have them normal. And when you go back to your 3D, you see that it's now properly done. And then we also have the slab exactly where we need it to be, on the ground level, on the ground floor level. So now let's try to create a wall. So we can create our wall. Let's go here, let's create our wall. I'll be drawing the wall on my story 1. So now I'm going to bring in the wall. So I want my wall to be 2 to 5. So that's 2 to 5, and I want it to be, the eccentricity to be 112.5. Then also this detail for the other one, 2.5. So now I can now draw the wall somewhere around here. where the ramp ends. Yeah, so the ramp ends here, so I'll draw the wall here. And when I go to my 3D, you see that we now have it drawn there exactly. You see that it's looking very cool. You can now go on to your loading and to decompose loading again, because what we decomposed the last time is already gone since we've added other structural members. So, and once you decompose your loading, you are good to go. So you can go and apply to all beams in the model. So, and as you can see now, you have your ramp well designed. Nevertheless, before you start analyzing, you need to draw your slab strips. And for the main slab, we'll be using analytical strips, and for these ramps, we'll be using fixed band strip, which is very suitable for our drawing, since there are no beams that are actually supporting the slabs, and the slabs are actually the round slabs are actually kind of floating. So we're going to be designing a fixed band strip for this, and we're going to be using analytical strips for this. All of that and more will be coming up in our next video tutorial, and we hope that you stay tuned to watch it. Don't forget to subscribe to our channel for more content like this, and we encourage you to hit your notification bell to be the first to see our latest video tutorials on Protastructure and related subjects on structural engineering, civil engineering, and practical applications of civil engineering. Thanks for watching, and bye for now.